Alright, in this series of videos we're going to be looking at dividing complex numbers. There are going to be a couple of videos, so watch these guys. And as we work through this, feel free at any time to pause the videos and try to get the answer before I do. Make sure that you're following along with me. So we're going to start off with doing something very simple here, I hope. Just simple division with complex numbers. You've got 36i divided by 9, and really you would treat this as though it were a variable. If you had 36x divided by 9, you would just do 36 divided by 9, which gives you 4, and then you're going to have the I. So it's just 4i. Okay. Now, as long as you're dividing by real numbers, there's really no problem. It's when we start having division with imaginary pieces that we start to really have some issues here. Okay, so for this guy, I mean, of course we could look at this and say 14 divided by 2 is 7, and that's all well and good, but you're still going to have an I in the denominator. And the way that we fix that is that I can multiply both the denominator and the numerator times I. So really you're just multiplying times 1, but it's going to help us reduce and simplify this guy. That gives me 14i over 2i squared. And as we saw already, I squared is going to be a factor of -1, and that -1 times the 2 is going to turn this guy into a -2 in the denominator. So 14i divided by -2, simplify that, and that just gives you a -7i. Okay, so this one was a little bit more difficult. You had to change the denominator so it would be a real number. So you multiply times the I. You convert the I squared to a factor of -1, which made that -2, and then you just did the division. So -7i. All right. So that was doing a real number divided by an imaginary number. Let's try this one. -18i divided by -4i. Now we could try to multiply both the numerator and denominator times I, like we did in the last example, or we can just realize that we can treat I as though it is a variable. I is not a variable, but it can be treated like one. Here these guys have a common factor of I, so the i's will reduce to give you a factor of 1. Of course you have a negative divided by negative, so we know that our result should be a positive. And then we're just going to reduce the 18 and the 4, and that gives us 9 halves. Keep things as improper fractions. Remember, it doesn't matter if they're fractions as long as they are reduced. So this is just a positive 9 halves. Alright, now we want to look at dividing things that are a little bit more complex. Let's look at taking a complex number, 6 plus 20i, and let's have that divided by 4. Now, in order for us to work this, we want to remember that this guy just has a single term for the denominator. So this denominator is common for both of these pieces in the numerator. So what we would have done back in 0308 is that we would have separated this into two smaller fractions. So 6 over 4 plus 20i over 4. When we've reduced this, or we've separated it into two smaller fractions, we now reduce, and it's just like the problems that we've already done. So 6 over 2 would reduce to give you 3 halves. They each have a common factor of 2. And then you just do the division here. 20 divided by 4. So that's 5. And then the I comes along for the ride. So this stuff is not the stuff that should be giving you problems. Let's look at the next example. The next guy is something that might cause you some concern. But if you break it down and you pay attention to your signs, there's really no problem with this guy. So 35 minus 25i divided by 5i. Now we're going to do the same thing that we did in the last problem, and we're going to separate this into two smaller fractions. So we're going to make this 35 divided by 5i minus 25i over 5i. Now I hope that you guys see that in this, in the second fraction here, the i's are going to simplify. We already had an example in this video where that happens, so these i's reduce. But I've got this I over here that's still in the denominator. He doesn't get to reduce. So what we saw in the second example in this video is that we multiply both the denominator and the numerator times I, because I divided by I is 1. So that's okay. It's going to give us an equivalent expression. So this guy is now going to equal 35i over 5i squared, and then we're going to have to simplify and reduce this guy just in a second. Over here the i's already canceled. You have minus 25 divided by 5, so that's just minus 5. So what's going to happen with this 5i squared? Well, the I squared gives you a factor of negative 1, so 5i squared becomes negative 5. Now that's your denominator. So to finish this problem, we have positive 35i divided by negative 5. That gives you a negative 7i. And then you have minus 5. Now it looks like we're done, except there's one small little problem here, and that's the way your final answer is written. Remember, when you're working with complex numbers, your final answer must be in standard form. So the standard form for this is always going to be your real part first, which is negative 5, followed by your imaginary part, minus 7i. So here is your answer in standard form.